and given equivalence relation, how to identify equivalence classes and how to determine all the equivalence classes. Right, so to determine all the equivalence classes, first of all you need to understand whether it is equivalence relation or not. So this problem I gave you yesterday, last time. So from this problem, so you check that this is equivalence relation, that is clear, right? Because checking equivalence relation is not a difficult job. To determine equivalence classes, what are the equivalence classes? So for example, if you look at, you choose any point 1 comma 0, equivalence class of 1 comma 0, what is it? So those points for which these points are related to 1 comma 0, right? That means what is it? Xy such that x square plus y square is same as 1 square plus 0 square. That is what our definition is. Ki two points are related if the sum of square of components are equal, right? Then these 2 points are related. That was a relation. That means what is equivalence class of 1 comma 0? Those points which are related with 1 comma 0, that means x square plus y square is equal to 1, right? And what is x square plus y square is equal to 1? X square plus
Unit circle.
unit circle, right?
Circle.
So this is equivalence class of 1 comma 0. So similarly, what is equivalence class of 1.5 comma 0, right? We can find. So our equivalence class of 1 comma 0 is same as equivalence class of 0 comma 1, right? Because 1 comma 0 and 0 comma 1 are in same class, right? They are in same class, so therefore their class is same. That we'll see in general detail, all details. So what is equivalence class of 1 comma 1.5 comma 0? Can you see this? Equivalence class of 1.5 comma 0, and you can check that this is same as those points for which x square plus y square is equal to 1.5 square, right? 2.25, and therefore this is a circle passing through this point, right, whose radius is 2.25. You check this, right? And therefore if you, so this is just for understanding, this is not expected in the, if our problem is key determine equivalence class, so this is not necessary, this is for your realization or understanding, right? This is not a part of proof of this, but to understand, if you are asked to find equivalence class of 1 comma 0, then you can find this. If you are asked to find equivalence class of, suppose I ask you third sub question ki find or determine equivalence class of, find equivalence class of for example 2 comma 3 point, then you have to find equivalence class of 2 comma 3, right? So whatever it, you can determine this. So this is what the point is, but not necessary every time you should find equivalence class of 1 comma 0 or 0 comma 1. That is for your understanding, right? If it is asked to find equivalence class of some point, then you can find that class, right? Then one more thing I should tell you, while checking something is equivalence relation, so in this case to check equivalence relation, so what we need to check first, reflexive, right? So reflexive is clear for any xy in R2, because our set is R2, we know that x square plus y square is same as x square plus y square. That means by definition of this relation, xy is related to xy for any xy. So xy is a notation. I am just selecting arbitrary point from this set R2. So xy, I selected some point xy in R2. and these are just symbol notations. You can say that key for any point in R2, this point is related to, right? So this is just notation. I am selecting some point. What is the first component of that point? Delta, and second component is the square. Doesn't matter because I am selecting arbitrary point. So notation, you choose your notation. Doesn't matter. It is not mandatory that what notation I am selecting. Same notation you should select. That is not necessary. You should understand this. Second thing, if you want to check symmetry, what I should check if xy is related to pq, right? If xy is related to pq, then what happens? X square plus y square is equal to p square plus q square. But this is same as p square plus q square is equal to x square plus y square. That means pq is related to xy. So please keep your mic off. Some people are keeping mic on unnecessarily and it creates disturbance. So here x and y, xy and pq, I am choosing two elements which are related, xy and pq. Not necessary you should select the same notation. You understand this. In previous problem, what I selected, what I did to prove the symmetry, I assume that suppose element AB is related to element CD, then I check that CD is related to AB. But I am just choosing a pair, AB and CD. AB is related to CD. So it is not necessary that you should select AB, AB and CD. Not necessary, right? What is the main point? If one element is related to a second, then is second related to first? That is a point, right? And therefore, notation doesn't matter. I can say that suppose this point is related to this point, whatever is this, then check that this point is related to this point. That is the meaning of this. Symbol doesn't matter. Remember this. Right? If this element is related to this element, then this element is also related to. So the idea is clear. What I want to say is it clear or not?
Yes.
Yes, sir.
Yes, sir.
Yes,
Right.
sir.
Then similarly, you try transitivity. Don't think that whatever I am writing, you should write down same thing, exactly same thing, same words, same notations. That is not necessary. Understand this. The general, you should understand abstract manner, general manner. If some element is related to some another element, then check whether the second element is also related to first element. That is the main idea. Similarly, you check the transitivity, and this relation is transitive. That is clear. And if you see this, what are the equivalence classes? What are all equivalence classes? All possible circles with center at origin. Right, all possible circles. These are all equivalence classes. Right, so how many circles? Infinitely many. So suppose you look at this small circle. Immediately after there is one more small circle. After that there is a circle. So that means this entire plane is filled by circles. Right, this entire plane is filled by this circle. Suppose you look at this point 1, 0. Then this is another point. Suppose 1.3, 0. Right, but in between again there is one more circle 1.1, 0. In between again there is a circle. So all possible, one more another. Right, so it is like uh, filling the plane. You are filling the plane by circles. Suppose you want to fill entire plane by circles. So what I will do, I will take this plane, then I will take immediately after that one more plane, then after that one more circle, after that one more circle, after that one more circle. So I will fill up this plane completely by increasing radius of these circles. So that means there are layers, one over another. So layers, right? Like you see the some mountains, there are layers of soil, one over another, right? So layers are layers of onion. If you cut onion horizontally, then there are layers. You will see the layers, right? So similar kind of situation. So layers. Now, if you look at equivalence class of 1 comma 0, right? What is equivalence class of 1 comma 0? Those xy for which x square plus y square is equal to 1. So this is actually one layer. Equivalence class of 1 comma 0 is a one layer. Right, equivalence class of 1 comma 0 is one layer because all points on this circle are in this class. Is it clear what I am saying?
Yes, sir.
Right, so
Yes, sir.
one layer. And therefore, what I will do now, I will just look at the what is a set of all equivalence classes. With respect to this relation tilde. Set of all equivalence. I will just now pick up each class. Right. So now recall, what do I mean to say that I want to pick up each class? For example, recall the previous example of students. Suppose this is a set of all students in the college. Students, all students. Right. So all students in the college. And you recall that the relation what I defined key x is related to y if x and y are from same class. Right. Do you remember this example? X and y are from same class.
Yes, sir.
And then what are the equivalence classes? These will be equivalence classes. The FYBSC,
Division.
A division, B division, SYBSC, Arts division, then animation and whatever departments are computer science divisions, then MA, MSc, whatever. All the classes. Now these are the classes, right? All students are now distributed among the classes, and these classes are actually equivalence classes, and equivalence classes are our real classes in the college, right? So what I will do, I will just pick up one representative of this class. Suppose I will call this as A. A is my representative, and this is representative B. Right. So what is the set of classes now? Set of classes. Set of classes. Right. So what I will do, I will class of A, class of B, class of C, and so on. This is a set of classes. Now, what is this particularly? What is A? A bar. Do you understand what is A bar?
Equivalence class of.
Ah, so it is a class of A, basically, class of A. And therefore, this itself, A itself is a set. But I am not assuming set now. I am just assuming representative and it is class. Right. Intuitively or implicitly, it is a set. But I will call this as an object. I will call this as an object now, single object, single class. Right. Because I want to assign classrooms to these classes. So what I will do? Right, I will assign some classroom. So this is A bar, this is B bar, this is another class, this is another. Now I will assume this as a single object, this as a single object, this as a single object. Entire class as a single object now because class A division is a class. So it is a single object now. Do you understand this?
Yes.
Yes, sir.
Right. So B
Yes,
division
sir.
is so B division is a single class, SYBSC single class, TYBSC single class, electronics, chemistry, mathematics, whatever. So single class. And therefore now I want to collect all the classes. So in this case, what are the classes? If I select the representative, so in this
Circle.
case, so circle is a class. So but if I look at a 1 comma 0, then minus 1 comma 0 in its class, right?
Yes.
Yes,
So
sir.
I do not need to write minus 1 comma 0 its class. Suppose John and Tom John and Tom are in same class, right? John and Tom are in same class. So I don't need to write their classes separately because they belong to same class. So if I want to write down all the classes, what I should write here from this? How will you get just from representative? I should get all the classes from representative. I will call the
X square.
representative of, right? If I take representative, so if I take representative, for example, 1 comma 0 and its class, then what happens? All entire class is there, right? When I say 1 comma 0 its class, then entire class is there. Then I don't need to say that class of minus 1 comma 0, because minus 1 comma 0 and 1 comma 0 are in same class, so their class is already included here. Am I right? Or I don't need to say that 0 comma 1, because 0 comma 1 is also in the same class. Minus 0 comma minus 1 is in the same class, so I don't have, or I don't have to say the class of this element, because this already class of there is same. So all these elements are there in the class of 1 comma 0. Is it clear now? Is it clear?
Yes.
Yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
Therefore, so how do I get all the classes? I have to just pick up all the points on positive x-axis. You choose any point on the positive x-axis and look at the class, its class. Look at its class. Is it sufficient to say that all elements are included in its class? Just choose any point on the positive x-axis and look at the class and look at all the classes. Entire plane will be filled. Do you understand this? Is it clear? You just choose any
Yes,
point on
sir.
the positive x-axis and look at its class and just consider all the classes. The entire space or entire plane will be filled. No need to consider other classes, right? You just take 2 comma 0 its class, then minus 2, 0 2, 0 minus 2, all elements in the class are there, and so on. And so ultimately, what is the set of all classes? Set of all the classes is x comma 0 x positive greater equal 0. So just this classes of x comma 0 and they take x positive. And one more thing, what is a class of 0 comma 0? What is a class of 0 comma 0?
Point.
Only single point. In this class there is only one member, 0 comma 1. That is the only class which has only one member, because there is no other member which is related to 0 comma 0 with respect to this relation, right? So do you understand what I want to say? I don't want list all the elements. Now I just want to call the representatives, and this representative will represent his class, and that the list of classes or this list of representative will uh, give the representation to every student in the college. Like same thing. I just want to look at the representative and its class I mentioned here. Is this sufficient? Will this include all the classes? Will this set include all the classes?
Yes, sir.
Yes.
Yes.
Right. Now you
Yes,
tell
sir.
me you tell me any member. I will give you this class is mentioned here. You tell me. For example, if you are saying that key, what is the class of 2019 comma 2020? This member is in R2. What is his class? Right. So you just look at the set x comma 0 and its class. What is x in this case? 2019 square plus 2020. Here, whatever is this number, I will take this number as x and 0. So look at its class. This class is same as 2019 and 2020. Right. So 2019 square plus 2020 square, that number is somewhere here. Right. 2019 square plus 2020 square. This is a number, right? And comma 0. Whatever this big number is here, and his class includes, this class includes 2019 comma 2020. You check this. Idea is clear what I want to say.
Yes, sir.
Very good. So the main point is set of all equivalence classes of R2 with respect to equivalence relation tilde is denoted by. This is denoted by R2 modulo relation. Modulo means with respect to, and this class is basically the x comma 0 classes of such elements where x is greater equal 0. So choose any x greater equal 0 and second component is 0. You look at choose as a representative and their classes. This will give you the complete list of classes. That's it. Right? And in some sense, this set. Now, how many classes are there? How many classes are there now? How many distinct classes you will get in this way? Equivalence classes you will get.
Infinite.
Infinite.
But that is correct. But how many numbers are on positive x-axis, right? Because you choose any positive number on x-axis, you will get one class. You choose one number on positive x-axis, it will give you another class. You choose one more from, then it will. So how many classes you will get? As many. How many classes you will get?
As many x are there.
How many positive real numbers are there? And therefore this set, how many classes, if you count the classes, how many classes are in your college? How will you do? How many representatives are there? Right? Suppose you just call representative from each class in some hall. You put a notice or one representative from each class should come meet in the some hall. Then how many representatives will be there? As many classes. Right?
Yes.
Is it right?
Yes.
So how many representative are there? So as many positive numbers on x-axis. So therefore, how many classes are in this set? As many representatives on positive x-axis. So how many? So this set is equivalent to the positive x-axis is equivalent to the set x such that x is greater equal 0 or set of positive non-negative real numbers. Right, so this is a very, you may not be able to realize this immediately, but from this picture it is clear how many classes you choose a positive real number, you will get one class. Choose any positive real number, you will get another class. So, please keep your mic off. So, in this way, you will get the classes, and how many classes? As many representatives we can have here, distinct, so that I will not repeat 0, 1 and 1, 0, -1. They belongs to same class, so I will not repeat that class in the list. I will choose one representative and one class, right? So no repetition is there, and therefore this will give you all the uh, classes, and therefore you can identify entire class. You can identify entire class by its representative. You can identify entire class by its representative. So this is identification. And what is identification? Identification is this positive x-axis only. You choose any point on this, that will give you one class. And therefore this set is equivalent to the non-negative real numbers or non greater equal 0. So positive x-axis for positive real numbers or non-negative real numbers, because 0 is also there. So this is a fact actually. Now you may find it is difficult to visualize, but you are dealing with such kind of things every day. Okay, where you do this thing every day. Suppose you have a cloth, big cloth, right? What you do? Suppose you have a bed sheet or blanket. What you do in the morning? You have a blanket. So what do you do in the morning? When you wake up, you fold it, right? What do? You fold it so that it becomes smaller. So you just fold here. First step, you fold here. Then what you get? I'm not sure how to draw the picture, but anyway, I will try. So what you do? You fold the blanket like this. You fold the blanket like this, right? You fold the blanket like this so that your shape becomes smaller. So suppose I fold blanket like this. First fold is this, right? First fold. So what I will get? In first folding, I will get like this, right? In first folding, I will get like this. First folding. Do you understand what I want to say? Now second time I will fold here. So in second folding or this side here, so I will fold like this. So how many times I am folding? 2 times, right? So I am folding second time like this. So what I get here, I will get how many layers? One or other. How many layers are there? One or other?
4.
4 layers. Very good. But how many space is required to keep this blanket in a rack or cupboard? So you need only this much space. But original blanket was this. And how much space is required? Only this much space is sufficient, which is very less, right? Which is very less. Okay. Now what we are doing, we are defining some equivalence relation. And what are the equivalence classes? You just look at this point now. In first folding, this point will go to this point. Now these 2 points are now in the same class. In first folding, am I right? Is it clear? Do you understand what I want to say?
Yes.
Yes, sir.
So what I am going to do, I am going to relate this point with this point. Then therefore these 2 points are now in the same line, vertical line. You just look at this point and this point are at the same place now, one or another. In second folding, what happens? This point will go to this point. Here are already 2 points are there, right? This point and this point will come over this. This point will go over this. In second folding, what happens? There are 2 points hiding one or another, one behind another. Am I right? Is it clear?
Yes, sir.
Yes, sir.
Very good. So
Yes.
now in second folding, what happens? Here already there are 2 points. Here are already 2 points. These 2 points are now one over another. These points are one over another. Now in second folding, what happens? These 4 points are at same place. These 4 points are at same place. Do you understand this? Now what relation I have defined? What relation I have defined? I make a line here, which is a central line, and 2 points are related so that after this folding, they will come, they are in vertically, or they are on vertical line. So these 4 points, 1, 2, 3, 4 points are on this vertical line. You just take a needle and just insert vertical needle here at this point. You can see that all 4 points are on this, this needle passes through these 4 points. Right. So this is my relation I am defining. Okay. What relation I am defining? After this folding, the points are in the vertical, on vertical line. This is my relation. And therefore, what are the equivalence classes? What are the equivalence classes? What are the equivalence classes?
The point.
Right. So
One point.
equivalence class of this particular point is all 4 points are in its class. Right. So equivalence. Suppose this is my x1, x2, x3 and x4. These 4 points. So equivalence class of 1. x1 is x1, x2, x3, x4. So equivalence class of this point. Do same thing for all points. And so ultimately what happens, how many classes you will get? Okay, for this point is class. This point will cover these 4 points. Similarly, this point will cover what? This representative will cover, right, these points, these 4 points. So these 4 points, you understand, these 4 circles, these 4 points now will come in the same class. Now if I fold this and again in second folding, these 4 points will come in the same place, in same class. Do you understand this? Do you understand this or not?
Yes, sir.
Yes,
So
sir.
how many classes you will
Yes,
get?
sir.
So how many classes you will get? As many points on this small sheet. How many classes you will get? How many points on this same
Points.
small sheet? So therefore, when we fold the blanket, the classes are the upper side of after folding, upper side. So those many classes you will get, and therefore number of classes is smaller, so that you can put this blanket in small space. Do you understand? This is a folding. Equivalence relation gives you folding. You are folding something, and therefore see the line. Previous example, our entire space set was real plane, but after folding what we get? Set of classes. After folding what you get? Do you understand? After folding what you get?
Line.
Only half line, right? Because this entire circle is now mapped to this point, entire circle mapped to this, right? And you do in the when Ganpati festival, you do, so you may have seen this kind of decoration. What you do, you just take this flower like shape and you can fold it. You just these two sticks together and you will get this like, you can fold it so that this uh, uh, put it in small space. This big flower, you can put it in small space like this. Just take these two sticks away and then fold it. Unfold and fold. If you unfold this, you will get plain, and if you fold it by this equivalence relation, then you will get only this line, segment, half line. So similarly, if you fold the blanket, you will get the only small part, and if you unfold, you will get the entire blanket. This is a philosophical fact, and you see, this is mathematics everywhere we are using in our day-to-day life. You have to, the only thing is you need to observe it. You have to relate to whatever mathematical calculations we are doing. You have to relate it with the day-to-day life. If you have if you improve, develop that ability, then you will be expert in mathematics, right? The only thing is you need to develop that ability. Don't think that ki we should select the same notations and same xy should be in there. No, not at all. Right. So around everywhere in each subject, each branch of science, everywhere, geography, history, everywhere, mathematics is needed lot. In day-to-day life, we are dealing with mathematics. Right. So why we fold the blankets and why we do many things. So this is a kind of folding, and therefore equivalence relation gives us folding. Right. So R2 modulo this equivalence relation is just half line. Do you understand? So is it clear what I am saying?
Yes, sir.
Right. So very good. So this is what something interesting you should realize ki what we do and what are the classes. Classes are the representatives, and representatives gives entire elements are hiding behind it. Right. So you can think about one more set. A is equal to set of P by Q. P and Q are integers. Only thing is Q is non-zero. Right. So all such integers P by all such numbers, real numbers, right? P by Q. For example, 2 comma 3, 5 comma 7, 100 comma 250, right? Such elements, all such elements are in this set. Only thing is we cannot select denominator as 0, so that will create a problem. So all possible such elements. So define a relation on set A as for two elements A by B and C by D in A by B is related to C by D if when two elements are related, if and only if AD is equal to BC. If A into D is equal to B into C, then only we will relate these 2 points. To understand this, I will give you example. For example, 1 by 2 and 3 by 5, are they related? Are they related?
No.
No, because
No.
1 into 5 is 5 and 2 into 3 is 6. So they are not same. So therefore these two elements are not related. Right. But you look at 1 by 2 and 2 by 4. Are they related?
Yes, sir.
Yes.
Right.
Yes.
So
Yes,
1
sir.
by 2 and 2 by 4 are distinct elements, but they are related because 1 into 4 is same as 2 into 2. So therefore these two elements are related. So that is what you can understand. What I mean to say that there is a relation. When and 1 by 2 and 2 by 4 are distinct elements, right? But they are related. And this is a very interesting problem because we are using this, you are dealing with this problem from your school, first standard. Why this problem is very important. So, okay, so now my first question is reflexive. Is it reflexive or is A by B related to A by B?
Yes. Yes.
Yes, because AB is equal to BA. A and B are real numbers. Integers. A and B are integers, and you can say that AB is same as BA by algebraic properties of real number, right? So AB is equal to BA. This is true, and therefore this is true. The AB is related to A by B is related to A by B. So answer is yes. Correct. Now, is this relation symmetric?
No.
Suppose
It is it.
Suppose A by B is related to C by D, right? That means by definition of relation AD is equal to BC. AD is equal to BC, right? AD is equal to BC means what? That
BC is
means
equal to 8.
AD is equal to BC means what? BC is equal to AD, same thing. That means CB is equal to what? CB is equal to DA. Is it same? Is it same? Right?
Yes, sir.
Now, but by definition of relation, when two elements are related, if A into D is same as C into B or B into C, whatever. Same thing, and therefore it is same as C by D is related to A by B. Correct? Because CB is same as DA. CB is same as DA. Therefore, this element is related to this. Correct? Is it clear? Is it correct?
Yes.
Yes, sir.
Therefore, A by B is related to C by D implies C by D is also related to A by B. Hence, this relation is symmetric. Right. So that is clear. It is very straightforward. Now transitivity. So transitivity. Suppose A by B is related to C by D and C by D is related to P by Q. then can you say that A by B is related to P by Q? Then A by B is related to P by Q. So you check this, right? So you check this, not very difficult to check this. So fine. Now this is I will leave it as exercise, but the main point is what are equivalence classes? So equivalence classes. What are equivalence classes? So for example, I am just giving example for understanding. In exam, if you are asked to equivalence classes, not necessary you should give example. You have to write down equivalence classes or whatever necessary explanation you need to give. For example, 1 by 2. What is equivalence class of 1 by 2? All the elements p x by y or p by q such that p by q is related to 1 by 2. Right. That means what are the elements p by q such that 2p is equal to q? 2p is equal to q. All such elements. That means q is 2 times p. Q is 2 times p. Whatever is numerator, its double should be the denominator. All such elements. Right. So for example, p 2p. P belongs to integers and p not equal to 0, because otherwise denominator will be 0. So all such members, right? For example, can I say that key 1 by 2, then 2 by 4 is 2 by 4 is in the class? Is in the class?
Yes, sir.
3 by 6 minus 1 by 2 is minus 1 by 2 is in the class?
No.
What is the numerator? Okay, let us check this. Minus 1 by 2 and 1 by 2 are in the same class or not? Not, right? Because minus 2 and 2, one side is minus 2, another side is 2. Correct? Therefore, only minus this is not there. So 4 comma 4 by 8 is in the class, and so on. You check this. You check this. Am I right? This is correct. This is correct or not?
Yes, sir.
So ultimately,
Yes, sir.
ultimately, what is a
Yes,
class?
sir.
Half times p, and you just p vary p over integers. Vary p over integers. So you can check this, but for positive here p should be positive, because if you take negative p, then minus half, and we know that minus half is not there in the class of 1 by 2 with respect to this relation. So p is positive. Now what is the class of minus half? You check this, right? You find out class of minus half, and similarly you find out all the classes of all the possible elements. Now point is, what are the all classes? What are all the classes? What are all the classes? What are all the classes? P by Q, PQ are integers, Q not equal to 0, and GCD of P and Q is 1. GCD of P and Q is 1. So if you look at all the classes, right? If you look at all the classes, see what you observe this class of half, 1 by 2, 2 by 4. What is the difference? Only 2 is common in the numerator and denominator. What is the thing here? What is the difference here? If you multiply by 3 numerator and denominator, then we'll get half multiplied by 3. then half multiplied by 4, half multiplied by 5, half multiplied by 6. Therefore, all multiple, half into some integer, half into integer, positive integer. Right, and therefore, what is a common factor? 2 by 4, 2 into 1 and 2 into 2. So whatever is common is cancel out. 3 by 6, 3 into 1 and 3 into 2. Whatever is common, 3 common, cancel out. And therefore, what remains only? 1 and 2. And so what is the GCD of 1 and 2? GCD of 1 and 2 is 1. Right, so this is what the observation. For example, what is a class of 2 by 3? For example, what is a class of 2 by 3? What is a class of 2 by 3? 2 by 3. Then 4 by 6.
2 by 3.
Right, 2 by 3, 4 by 6. Then 6 by 9. Is it correct? 8 by 12.
Yeah.
Right. This is a class of 2 by 3. And if you observe 4 by 6, it is 2 into 2 divided by 2 into 3. Just whatever is common, cancel out, I will get 2 by 3. So what is the representative? Representative is just whatever
2
is a
by
common.
3p.
So representative is 2 by 3. And therefore class of 2 by 3 is what? Just multiply by 2, 3. To numerator and denominator, you will get entire class. So that is what representative is 2 by 3. Right. And this is you are using in day-to-day life. For example, 2, 1 by 2 and 2 by 4. What is the value of this number? This real number is same. Am I right? Value of 1 by 2 and 2 by 4 is same.
Yes.
Yes. Yes,
Same
sir.
as value of 3 by 6 is same
Yes.
as value of 4 by 8 and
Yes.
so on. So
5
why
by
we are saying values are
Yes.
same? Because they belongs to same class. Right? What we are seeing? They belongs to same class. Therefore, their values are same. And therefore, I don't consider these elements as a distinct elements. I consider that all these elements are same. 2 by 4, 3 by 6, 4 by 8, all are same because they are in same class. Right? And therefore, 1 by 2 is only representative. All are hiding behind it. 2 by 4 is there, 3 by 6 is there, 4 by 8 is there, right? 5 by 10 is there. All are behind this. This is just representative and all are hiding behind it because they have same value. And you are using in day-to-day life, the value of 2 by 4 is same as 1 by 2. Value of 3 by 6 is same as 1 by 2 because they are in same class. Is it clear? Do you understand the idea? Am I right?
Yes, sir.
Okay. So this is what the set of rational numbers. So what is a set of rational numbers? What is a set of rational numbers? We denote it by Q. In calculus, you must have learned this. Key set of rational numbers, P by Q. P and Q are integers. Q not equal to 0. And if you assume moreover, key GCD of P by Q is 1. Right, GCD of P by Q is 1. If you assume this also, then we are assuming distinct members now. When we say GCD is 1, and every time we don't need to write down class of 1 by 2. So generally in our day-to-day calculation, I just write 1 by 2. Because 1 by 2, what do I mean? The class 1 by 2. Because 2 by 4 is same as 1 by 2. Right, and in day-to-day life, I just call representative 1 by 2. I don't worry about the other members in the class. Right, so this is a set of rational numbers, and we know that key rational number 1 by 2 is same as rational number 2 by 4 because they are in same class. Right. So I avoid repetitions because 1 by 2 is same as 2 by 4. So I avoid repetition as a value, and just I will write 1 by 2. I will not write 2 by 4 because 2 by 4 GCD of 2 and 4 is not 1. So whatever is common cancel out, and what remains only 1 by 2. So that is what the set of rational numbers. Correct?
Yes, sir.
Right. So Now, whatever we did so far, for example, 2 by 3 is in the class, or 4 by 6 is in the class of 2 by 3, but 2 by 4 by 6 is not in the class of another class, right? 4 by 6 cannot be member of class of 1 by 2. 4 by 6 cannot be member of class of 1 by 2. That is true from this, right? Because if 4 by 6 is in the class of 1 by 2, what happens then? 1 by 2 is related with 4 by 6. But if 1 by 2 is related to 4 by 6, that means 1 into 6 is equal to 2 into 4, which is not true. Right. Therefore, 4 by 6 is not in the class of 1 by 2. So that we can observe from this example. Now, our next job is to prove these things in general. If two members are related, then they are in the same class. If members are not in the same class, then their classes are completely different, disjoint, distinct. So such general ideas we want to understand. But the only thing is, you should have a feel of this equivalence relation and these classes. What exactly this means, and what is the philosophy behind all these equivalence relations and classes, right? And how we use in day-to-day life. That feel is very important. Once you feel these ideas, you get feel of these ideas, then you can understand the theory part, general abstract part, right? So uh, is it clear? Do you understand what is going on?
Yes, sir.
Did you did you
Yes,
learn
Yes,
sir.
sir.
did you learn relations before?
Yes, sir.
In 12th standard, you had this kind of things, relations or this?
In 11th, a bit of introduction was there.
Yeah, but see, the point is you should be able to understand, visualize the relation, and once you visualize